Hello. How's everyone doing? Hey, fine, thanks.
Good.
And that's you on mute.
Hey,
Yes.
good point.
All right.
Thanks.
Put it in. Um, all right. So I think pretty much everything on the agenda is really all about the orchestrator, um, with a quick discussion about how we want that to interact with the MDS failover stuff. Um, the agenda has a link for these slides that I used for the Ceph day a couple weeks ago. I think probably many of you have already seen them. Um, I can flip through them really quick if people want, or they're sort of familiar with all this stuff. We can skip it. Anybody want to see them, or
Briefly, maybe?
just you guys see that?
Yes.
All right. Right. So the orchestrator, there's a common API in the manager. That's the key part, and a bunch of common code that sits on top of it. And it calls out to implementations that go and deploy daemons, basically. So that can be either Rook or SSH. There are other implementations too, but they're in various states of partial completion and are unlikely to be maintained, at least by the core team going forward. So Rook and SSH are sort of the two we're focusing on. Rook for Kubernetes environments and SSH for non-Kubernetes. So the goal is to have something that's really simple that works out of the box so that you can have a complete cluster install that's as few steps as possible. The instructions are simple. And we also want to have a full set of day two operations like replacing disks, adding nodes, removing nodes, all that stuff. We want to limit the dependencies on external tools just so that it is easy to deploy and build and maintain and all that stuff. And ideally, we want this to be the documented default install process for Octopus. So right now, the docs talk about Ceph deploy sometimes. They link to Ansible, Rook, but it's all very confusing. And most of the instructions on day two operations sort of wave your hands at restarting daemons and such. So the idea is to have sort of a normalized way that you can do this, mostly through the Orchestrator API. So it won't actually matter whether it's Rook or Ceph or SSH. But either way. So the idea is to fully replace Ceph deploy, Ansible, DeepC, Puppet, all that stuff with something that sort of is a canonical, simple way to do it. Everything uses containers using the Ceph container image. Conveniently, the containers avoid all the complexity of packaging tools. So the instructions don't just say if you're on Debian, type apt this. If you're on these 5 distributions, type RPM this. It's all replaced by a single string. And I had this epiphany the other day. I finally realized why it is that it's so much easier. It's that with the packages, you have to like install repos and assigning keys and so on. And with the containers, it's literally just a URL off of Docker Hub or whatever. It's like eliminates that one step, and it's the same regardless of what your distro is. That's good. And then the idea is basically you do a bootstrap that brings up the monitor and manager, like a very simple single node cluster, and then everything else is a day two operation to add more monitors, add OSDs, add MDSs. Ceph daemon is the low-level tool that actually deploys the containers on a local host. So this is sort of a low-level command tool. It deploys daemons and containers controlled by systemd, and it has cluster isolation, so you can have daemons for multiple clusters on one host. It has a bootstrap step. Oh crap! Sorry. It has a bootstrap step that will bring up that monitor and manager, and then after that, there are several more steps Okay. So yeah, there's Bootstrap, and then it has some management stuff for humans. So there's like an enter command that will let you launch a shell or run a command inside a running container. There's a shell command that just runs a shell or runs a command in a new container. There's something to tail the logs, basically the same as podman logs -f or whatever that passes all the right arguments for you. And there's cleanup stuff that will remove all traces of daemons. And it's a single Python script, so it's easy to, you can just curl it and run it. So it's designed to be really easy to use. It relies on systemd, works with Python 2 or 3. You can use Podman or Docker interchangeably. Those are function more or less identically, and it needs LVM for Ceph volume. But otherwise, the host doesn't really need anything else. The base Python install. So you can just curl it and run it, and it's going to work almost all the time, except for installing Docker or Podman usually. The Bootstrap is really simple. You just curl it, you chmod exit, and you run it. There's only one required argument. That's the monitor IP to use. We could actually teach it to pick one automatically if it can, although that requires extra Python libraries, so we didn't do that. And at the very end, it gives you a URL for your dashboard, or you can run this command to launch a shell that you can do Ceph CLI commands. So super quick and easy to get at. So you can do shell, ls lists daemons on the node, logs will tail logs. You can delete clusters. By default, everything logs to standard error, so it goes into journald. But we also set up varlog Ceph directories in sort of the traditional style. So if you want to use traditional logs, you can do a config option and those will get turned on. And all the paths are set up regardless of which you choose. This is also convenient if you need to go debug a cluster. You can just flip the switch and you can get the sort of the fire hose of logs to do that. The paths are a little bit different. Inside the container, it's all the usual log locations and path locations. Outside, we put the FSID in the path name, so you can have multiple daemons from multiple clusters coexisting. Keeps things nicely isolated. You can easily test, bootstrap lots of clusters on the same host, all that stuff, as long as you have enough monitor IPs. And the unit names are a little bit different also because they're tagged with the FSID. There's an adopt function that will take old daemons and just rename the directories basically so they're in the new style. So to take an existing old cluster and just convert it to the new style is basically a big for loop. It's pretty straightforward. There's going to be an Ansible playbook, I think, that'll do this and so on. SSH Orchestrator just runs this over the network. So SSH can basically do exactly one thing. It's run Ceph daemon on a remote host. That's the only way that it ever actually uses SSH is to do that one thing. And it does that by running the Python interpreter and piping the script to the Python interpreter. So Ceph daemon doesn't have to be installed anywhere. It can just, as long as you have an SSH key, you can just run the command on a remote host. There's a separate mode that requires the Ceph daemon package to be installed, and it does sudo to run it. So you can sort of limit the security scope a little bit. Both are tested and supported, but the root SSH mode is the easiest one to set up. The shell gives you a shell. It's pretty convenient. You can add new hosts. So in this example, I'm adding the SSH key to the root user. After you do the bootstrap, you can add a couple more hosts and then add more monitors. There are sort of extra arguments required to specify the IPs and such. This hopefully is going to get simplified soon, but you can do that. You can deploy more managers with one command. It'll go add more managers. You can list all the services, all the devices on all the different hosts, and you can create OSDs, services that shows all the running containers, what hosts they're on, what version of Ceph they're running, and so on. On their commands, so like restart daemons, redeploy daemons with the new container image, stuff like that. As I mentioned, there are 2 security models. Upgrades are currently being worked on. That's what I was working on this week, basically to automatically go and redeploy containers on a per daemon in the right order and so on. The other thing is right now the dashboard is initially only going to know how to do a few different things with the orchestrator, like replacing OSDs, but eventually we want to do more. Paul Kuzner in particular wants to figure out if you can do a guided install, focus on that so that after that bootstrap step, you can go to that URL and deploy the rest of the cluster using sort of a GUI wizard thingamajig. We'll see how that goes. And yeah, that's mostly it. It's all targeting Octopus. That's a quick summary. Yeah, last agenda page. So we have a bunch of stuff. There's a Trello board to track all this stuff here that I can put up. I think it should be public now. I didn't click the button before. And there's a line basically of all the stuff that I really want to get in for Octopus. I think we'll manage. And then there's a bunch of stuff that's optional, like NFS gateways and iSCSI and so on. The big next step is around the monitoring stack, so deploying Prometheus and so on, so that the dashboard is fully functional. That's sort of the main current area of discussion. Yep. Any high-level questions before we jump into the? Any high-level questions before we jump into it? All right. So MDS affinity. This came up because the way that the Orchestrator API deploys MDSs, it's grouped by file system. And this is done that way because it maps basically to the way that the Rook CRD works. So when you deploy a file system, CRD and Rook, there's the number of metadata servers to go with it. But we recently changed it so that the standby metadata servers aren't actually assigned to a file system. They can sort of float between whatever file system needs it. So we need to square the circle or whatever it is, figure out what the path is. Patrick.
Yep, I have a Etherpad set up for this. Link it in the chat. So I think going forward, I see two dimensions we want to consider when assigning MDSs to a file system. One is file system affinity, and the main reason to want that at all is you have different file systems with, and you want maybe bigger MDSs on a production file system and smaller MDSs on a testing one. So I think having some kind of file system affinity makes sense. Then there's another dimension we wanted to consider, which is availability zones. If we have a stretch Ceph cluster, we want to be able to have an MDS in each availability zone, and then maybe use something like subtree pinning to pin certain subtrees to those MDSs, those MDS ranks, so that clients in that zone only talk to the MDS, because presumably they're only going to be using that particular subtree. So we need to have metadata associated with each MDS, corresponding to which file system its affinity should be and which availability zone it's in. And I think that can just be sent off to the monitors in its MDS beacon and set via config variable by Rook or the orchestrator, SSH orchestrator. The next thing we need to do is look at set up a file system availability zone, or an availability zone to a rank. I have an example command of what that would look like. Just be another piece of metadata we have in the FS map, noting where that rank, which MDSs from which availability zone should be used for that rank. As far as standby replacement, I think it'll first prefer MDSs in the same availability zone, then the file system affinity, and then finally it will pick any available standby. I think we should depart from previous behavior where we never needlessly, or we never fail over a running rank deliberately, but I think we should change that so that if we are using a standby in some other availability zone or for just some generic standby, if another one becomes available that is has stronger affinity, we should just do the failover so that it corresponds to what the operator wanted. Some of the open questions I have, I've listed in the Etherpad. But it sounds like, Sage, you were going to say something, so I'll pause.
Yeah, let's talk about the FS affinity first, and then the AZ affinity second. I think the FS affinity is simpler. Would the way to do that be like a config option like MDS affinity FS name or something equals foo?
Yeah, I think
option
so.
on the MDS, and then that would get fed. Yeah, okay. So one thing we just did with the RGWs was that we named them client.rgw.realm.zone.id, and the config options are now hierarchical, even below the type. So you can have a config option where like client.rgw.realm has rgw realm equals foo, something like that. So we could do the same thing here, where when you deploy, the metadata service could be named by the file system. It'd be like mds.fsname.id, and then mds.fsname would have mds affinity fs equals fsname, like that.
Yep, that looks pretty simple.
Okay, cool. We can do that. Mostly the orchestrator is staying out of the like game of setting configuration options. I'm trying to just push everything into the on config, but in the RGW case, it does do one thing, and that's just set this option. So when you deploy a group foo, it will go set the option for mds.foo to have mds affinity fs equals foo.
That would be done by the manager?
It would be done, well, right now in the RGW case, the SSH orchestrator is doing it when you create it, just so that when it actually runs the daemon, it doesn't have to pass an option that says, by the way, you're in this zone or whatever. It sort of implicitly gets that just from the way that it's named. So I think I'll probably just do the same thing here, and if we think of a better way to do that, then we can always change it later.
Yeah, that makes sense.
Okay. Okay, so I think that solves the
other thing
immediate
about
issue.
this is slightly divergent. I'm wondering if we should, if Rook should stop having a file system CRD. Now that, or at least in Octopus, we would want everything to go through the manager. I'm not seeing why we want Rook to be creating file systems anymore, and then setting up MDSs. Shouldn't that all go through the manager?
The way that the manager creates MDSs in Rook is to create the CRD. But the CRD could probably be, I think probably what we want is the CRD to only have the daemon definitions and not the information about the file system except what name it is. And so the file system's already created. And conversely, in Rook, when you create a file system CRD, because half the CRD is just for us to control it, and half of it is to provide a Kubernetes API for people to deploy file systems. And in that latter case, the file system CRD should just call the manager fs volume create or whatever it is to create the file system in the normal way.
Yeah, makes sense.
Okay. And it'll be a little bit circular because probably when you do that, it's going to go try to make sure that the file system CR exists, but it already does because it's the thing that triggered the. So we'll want to make sure that isn't too broken. But yeah, okay. I think there's this general pattern with Rook where all these CRDs are going to have a way where they're just managing the daemons when you're like managing this cluster through the dashboard, say, or they're doing the whole thing if you're managing everything through the Rook or the Kubernetes APIs, CRDs.
Yep. Okay.
Okay. For AZ affinity, can we just use crush location for that? Where the MDS basically reports its crush location, and then monitor decides if and how and whether it should pay attention to that. This is currently what the OSDs, no, something does this. Clients do it. Clients, you can set crush location and it will drive the affinity, whatever, the like local read stuff, although that's not actually normally enabled. There's one other case I think we're doing this, but I'm blanking exactly on what it is. But it means that we have a common language to describe locality and where things are placed in the cluster. So in the case of you want to say AZ US East 01, for example, it would just be the same crush type that you're also using to describe that OSDs are in that particular location.
Yeah, I've never done that before, but I don't have any objections to it.
Okay. Because I think Rook is already doing this in some cases where it basically is just specifying the crush location on when it runs things on the command line, if it knows, because in many cases it knows, for example, what region and zone it is running in an AWS because Kubernetes has nodes labels appropriately. And on bare metal, we have a set of standardized labels also that we can use. So if we do that, then ideally we'll have sort of proper location labeling for all the daemons, not just OSDs. And we can use that to describe how things are done. Cool. Okay. I think probably a Rook to do. But this for all daemons, not just. Yeah. Okay. Okay. I think actually the manager will already have that information from the config stuff that's reported to the manager. You don't have to necessarily include it explicitly in the beacon. Although you can actually, it might be easier to do that just for.
Yeah. I don't know.
Either way.
Okay.
Yeah,
so the setting the ranks availability zone, does that make sense, or should?
I was wondering that because I think it makes sense only because you're pinning to ranks already. But what you really probably want to do is you want to pin subtrees to locations and not a rank, and then pin that rank to the location. So it's sort of this annoying number that's the go-between.
Yeah.
I mean, ultimately, that's what mechanically will have to happen, right? A particular rank is mapped to a zone, and then we send map daemons to that rank and subtrees to that rank. But it might be that the user interface that eventually we want is actually a little bit more friendly, so you don't have to think about which rank is which.
Yeah.
It's probably fine for a first pass, that we can always sort of make things nicer later.
Yeah. It would be more friendly if we could set the availability zone on the tree, and then somehow in the back end that would expand the max MDS, and then an MDS would be spun up in that availability zone, and automatically the tree gets pinned there.
Yeah. There's sort of this secondary issue also where implicitly means that we want to be able to schedule, not just control through the orchestrator interface, not just control the number of MDSs, but like where they're distributed and where they're placed cluster. Right now, you can pass down labels, but it's for the whole group. It's not for like subsets of MDSs within that group. And so before this will be fully functional, we need to figure out how to like make that a little bit more granular, I guess.
Yep.
I don't think I want to bite that off for Octopus. I just want to get the basics working. But for Pacific, you can think about that.
Yeah. I have someone on my team, Melinda, who's going to work on probably another manager plugin, which will deploy MDSs in response to a degraded file system. And one of the things we should look at is the availability zones on the ranks and make sure that there's an MDS in that availability zone. And then sufficient standby is all of that.
Yeah.
So ideally, the volumes plugin would only need to set the max MDS in any kind of rank affinity via another API in the volume interface. And then in the back end, the other manager plugin will make sure everything is correct.
Yeah. Yeah, that sounds right. Okay. Cool. Sounds good to me. Anything else? Anything else on this topic?
Just the questions at the end, but I don't have good answers for them. They're also not needing to be immediately answered. Save it for future work.
Yeah, I think. Yeah, I want to think about that. It would be nice if you had
That's all I got.
at least the pool that's used for the MDS journals be localized. The directories and the rest of the file system are probably harder to, and less important, but for the journaling, probably updates be nice.
Yep.
Cool. Okay. Good. All right. I wonder if actually we should talk about the labels and scheduling next. Joshua on the call. Yeah, there is. Bastion. Because we were just talking about this. So you mentioned that the Ceph volume create or whatever would only have to pass the max MDS, the size. We were just basically trying to get to that point with the SSH orchestrator. So with this pull request, it's adding labels. Well, labels are already there, but it adds some scheduling, basically, like a really simple scheduler for SSH. And the goal there is that to get away from currently when you deploy something, you have to pass a list of host names every time you deploy a daemon and to tell the SSH orchestrator which node to deploy the daemons on. So the goal is to get away with that. The initial idea was just that if the nodes are labeled based on type, so you maybe have some nodes labeled for MDS, some for OSDs, some for RGW, whatever, it would just pick among those nodes automatically. And then, or if you don't have any labels, then it would just sort of indiscriminately pick a random, well, not a random, but pick a node sort of across the whole cluster. Initially, the scheduler in that pull request is like just trivial. I think it just picks a random set of nodes. But eventually it can get smarter, like the node with the least services on it and so on. But there are a bunch of questions there about because they're I think a couple different things. You can specify the number of daemons, you can specify a label, or you can specify a list of nodes. And if you specify more than one of those, how should those things intersect? So for example, if you say I want one MDS, but I have 5 nodes labeled as MDS nodes, I think it should just pick one of those out of those 5 using whatever the scheduler intelligence is. If you pass an explicit node list of 5 nodes and you say, I think it should do the same thing. Passing a node list and a label, I think, doesn't make sense. I think the fuzzy part in my mind is, would it ever make sense to say that I'm not going to specify the number of daemons. I'm just going to specify the label and count how many nodes are labeled as such and deploy that many daemons. Like, is there really a case where that makes sense?
I mean, that kind of depends on how easy it is to apply those labels. Just speaking from deep sea experience, we had this role thing too, and you could apply those labels in various ways, like pick a host name or pick a host name glob or something like that. We had various other ways, but it always ended up being a host name glob that applied the roles, and then we just blindly, everything that has an MDS role goes out and deploys an MDS. And that worked quite well, although we had it more complex, just as a point of experience.
And that worked because users would name their hosts based on what the type of node it was?
Yeah, I mean, they could either do that, but so basically we would give them a way to say, okay, this hostname glob is all role MDS.
Okay.
And yeah, like sure, like enterprise customers would have much control over their host names, so they would just include MDS in the host name and have an easy way to glob this. But there are certainly other ways, but it was rarely that we saw people trying to match on other things than host names and to have like wacky host names where they go, okay, this glob, but only the first the first 4 nodes of this. Like we had all this built in, but it was never used.
Okay. I'm wondering so we haven't contemplated doing the globs really for SSH, except for that one discussion that we had the other day. But I think partly it doesn't make sense to me because I'm not imagining that this is really written down somewhere. Like if you're writing like a manifest file or whatever you call it, then the globs are convenient because you don't have to type out all the host names and copy and paste a list of hosts around into different subsections or something like that. But in this case, the way that hosts are added is like via an imperative CLI command that says add host. Or I would imagine if you're doing it through the dashboard, as you add a host, you would like check the boxes for which labels you want to apply to that host. Or more likely, probably what I would love to see would be like a dashboard change that lists all the hosts and lists all the labels in like another column, and then has like easy checkboxes or something so you can easily like relabel nodes. Like if there were a column for each label, for example, or something that just makes it really easy to like select multiple and just like apply a label to them and do it so that you have a visual to do it.
Yep. For a GUI, that totally makes sense. This whole globbing thing was really based on having those globs in a file.
Yeah.
So use case certainly changes when you have a CLI or even a GUI.
Okay.
Right, we already have that in the dashboard for OSD creation for what it's worth. So you get a table that lists all the hosts, all the disk drives attached to that host, and then you can create your drive group specification by simply selecting the criterion that should match. Then you get a result table that lists all the disks and hosts that this would apply to, so you can then proceed. So
okay.
Something like that would be suitable.
Okay. I know it's super late in the game, but it might be, if we could think about a page that shows hosts and labels. I'm sure there's already actually a page that shows all the hosts of the cluster.
Yes, we
what
already
daemons
have
are on there.
that.
But adding the labeling part.
If the orchestrator returns that data, that should be fairly straightforward.
Okay. All right. That might be something that's worth trying to squeeze in. Okay. All right. Well, that
And
pull request. Sorry, go ahead.
sorry, for the CLI, you just propose to have that part of the add host. Is that right?
We could add it there. It isn't there right now, but we can just add an extra thing that lets you specify labels. There's
Yeah.
a separate command for adding and removing a label to a particular host.
Okay. Yeah, I think
Would be like,
I like that much better, and that should be fairly straightforward to add some kind of globbing there. That would make it quite convenient.
yeah, okay. Yeah, that's already in the tree, so feel free to propose a change to that.
Yeah, so in response to your question earlier, Sage, about whether we should deploy based off of labels, that is, if I add a host with a given label, with an MDS label, should an MDS automatically be deployed there? I think it's kind of the approaching the problem in the reverse direction, deploying services based off of host labels. I would think we would want to only have the orchestrator always drive, or whatever is adding services to via the orchestrator should drive when we deploy new daemons. So like if
How many?
As far as how many there are. So if I increase max MDS, then this new MDS module would go out and deploy a new MDS, and eventually that MDS node would be used, or maybe not.
Okay. One thing this occurs to me actually. One thing that's missing right now from this is actually no. So right now you pass the count to the orchestrator MDS update to adjust the number of daemons, and that's independent from the max MDS. So if you want some number of standbys, then you just use a larger number than what max MDS is. I think that's okay.
Do we see that, like, for SSH, that kind of makes sense to me, like adding nodes with labels. And the SSH orchestrator module would keep track of those labels. But for like Kubernetes, I don't think Kubernetes administrators will really want Ceph actually modifying the Kubernetes labels on nodes. Like, they will come with their own labels and like, be labeled via a different mechanism.
You can't create like namespace private labels. They're all sort of a global.
Yeah, I'm pretty sure.
Okay.
Like that's.
Yeah, I think whether or not. I forgot about that. We could just make the Rook orchestrator report the existing labels up, or at least all the ones that are prefixed with Rook, so that you'd have to modify the Rooks through Kubernetes, and you couldn't do it through the dashboard and CLI, but they could still be. You'd at least have visibility in terms of what they are. Or we could have an optional switch or something, like if they want to go into Ceph driving Kubernetes mode, then we could actually update those labels or not. But I think nothing.
Yeah. Yeah, I think it does get a little complicated because Rook also can, like, have multiple Ceph clusters in a Kubernetes cluster.
Yeah.
And so, like, you're like, I want this node to be able to run monitors. Might be a sort of like, I want this node to be able to run monitors for this specific cluster, or for this other specific cluster. So I don't know if we want to make sure that in Ceph, like, our label matching is programmable with some like sort of sane default.
My assumption would be that we would make the Kubernetes labels have to be prefixed by like the Rook namespace or something, so that effectively those labels would be private to that particular cluster. And then they could even be like edited by the time they reach Ceph. You'd only see the suffix and not the prefix, something like that.
Yeah, and that's certainly
okay,
an option as well.
And I think I can
I can also see the it seemed like a good scenario from dashboard. Like admin is configuring things. He wants to go to his dashboard, put the daemons on this node, and so yeah, let's go label the nodes automatically. It seemed like as long as it's a predictable prefix or something that's obviously belonging to Rook or Ceph, that's like a valid thing to add the labels to nodes.
Yeah, assuming Rook has the right permissions in Kubernetes to do it.
Right, and we do request node access already for detecting nodes, and I think we can add labels to, well, if we can't, we can add that permission pretty easily.
Yeah. Okay. And I guess the way I'm thinking about this is that the node labels are just one way of controlling where things are scheduled. If you leave them off entirely, then the scheduler would basically just work with the set of all nodes for every scheduling decision. And so nodes, like Kubernetes normally works today, things are just randomly spread everywhere. The SSH one can work the same way. Okay.
Right.
All right. Maybe I'll add that to the to-do list too. I'll add a new list for Rook. Okay. All right, we're going kind of out of order here. So unfortunately, Paul Kusner is not here because it's like 2 a.m. or 3 a.m. or something in Australia. But he sent out an email, I think, earlier this week or last week, Lens, about basically taking, so in the last, for downstream for last release, he wrote this whole thing for Cockpit. That's a whole GUI-based install thing that drives Ceph Ansible. And so he literally like just did this for Nautilus and Ceph Ansible. And so he was basically going to look at re-implementing basically the same thing in the dashboard so that after you do that bootstrap, you can click the link and you can go into a guided wizard thing that walks you through adding new nodes and setting up your SSH keys, deciding which nodes get OSDs and all that stuff. And like starting that work immediately, hopefully in time to have something that follows shortly after Octopus, or maybe there's an initial version for Octopus and we backport it, or I don't know, whatever. But try to get that done quickly. The nice thing about having him work on it is he just literally did it, and so as far as like how to structure it and scope it, it's all sort of front of mind. Yeah. Lens, I can't remember what was the status. Next step.
I replied to him and waiting for his reply at this moment. So
okay.
When he contacted me about 2 weeks ago, I couldn't get around answering because I was on sick leave a few days. But back then he was basically in fact-finding phase and trying to figure out whom to talk to. So I replied, gave him some pointers about people, also looking into this and actually interested in how we can put this together. But I don't know what he has been up to since then. We haven't got in contact yet. I basically suggested it's probably the easiest for him to simply join our daily stand-up since that's in EET morning time, so that should be easy for him, or easier for him to attend.
Yeah.
And we're having that every day, so he could just show up and
Perfect.
figure out the next steps.
Okay. I should mention most people might not be aware, but we did add a Orchestrator daily stand-up every day. That's 15 minutes before the core stand-up, and so all this orchestration stuff we're meeting daily. And we just added one on Wednesday afternoon that is will work for him basically. So that's coming up in like 4 hours or whatever. I'll sync up with them then.
Just a quick question. So Paul is basically kind of redesigning what he did in the Cockpit integration based on the SSH orchestrator this time.
Basically, yeah. The idea would be to have a similar guided workflow, but implemented in Angular in the dashboard, driving the Orchestrator API. Yeah.
Cool. Looking forward.
Yeah. And I think one of the things that we should be sort of thinking about as we do that is, since this is all sitting on top of the Orchestrator API, it all should work in theory for Rook. And so there could also be a guided Rook mode where you paste a canned YAML that just creates one monitor, one manager, and then you go to the dashboard and then do the rest of the Rook stuff instead of manually constructing the CRD for the cluster. So in theory, hopefully that'll all be possible as well.
Yep. Certainly sounds exciting and interesting. Question is, I think from an upstream perspective, having something like this as part of the project makes sense to kind of lower the barrier for people new to Ceph to get going and have a nice GUI for that. I do see some conflict potential when it comes to how much of relevance this is for downstream products that may have other requirements, like maybe putting your cluster configuration under revision control. We're more working on bootstrapping this from the command line in a way, and maybe instead of having to go through the UI to add all those hosts manually, well, we maybe just need to be a bit more clever on how we do this on the UI. But we should make sure that it's not adding overhead by clicking around too many times. While on the command line, you would just have a wildcard for the same operation, just to give you an example. So I've seen the work that he's done on the Cockpit installer. What isn't clear to me yet is how much of that is already supported by the orchestration layer underneath, because that's the prerequisite before we can even talk about putting the UI on top. So, but the things that are needed here are on our agenda anyway. Right now, or so far, our focus from a dashboard perspective has been looking into how we make day 2 operations based on the orchestrator easier. So the daily disk OSD maintenance was our first step, because that's usually the stuff that you are working most of the time, while the installation is a one-off thing.
At one time. Yeah, exactly. Yeah.
So that's really the caveat and the trade-off that you have here. You're putting a lot of energy and resources into something that's used once. But then again, some of this can, of course, be repurposed and is part of the day 2 operations as well. So.
Yeah, exactly. Yeah. Trying to kill as many birds with the one stone and then get us on the right path.
And I mean, with what we have in the dashboard already, I mean, basically starting from a single mon manager lead node in a way, and having SSH Orchestrator already configured to have SSH access to all the other nodes in your cluster, you could basically at least do the OSD deployment in the dashboard already by using the OSD add function that we have. So
and
that part is done, but it's more about the other services, RGW, NFS, those kind of things.
Yeah. And those ones, fortunately, are easier. OSDs are sort of the hardest one because you have to map to physical disks. So I haven't been following the drive group stuff super closely, but based on what I was told yesterday, it's actually pretty close to what you need, because you have device filters, and then you also have a host filter. So you can apply a group to a whole collection of nodes, or even all nodes. So you can sort of.
Next time you're playing around with SSH Orchestrator, take a look at the dashboard and see how you like that OSD part. I would be curious to get your feedback.
Yes, I will do that. Yeah.
So next step from our end, until we have synchronized with Paul about additional features, is being able to remove OSDs. And once that's done,
Kiefer's
OSD replacement is another one that we have. Yeah, Kiefer's the primary guy working on that. So that's the current lay of the land, and our hope and expectations of things that we can get realistically in before the official Octopus feature freeze.
Cool. Okay. Yeah, I mean, to your earlier point, that the goal of all this is to make sure everything is sitting on top of this common orchestration API. So whether you're driving it, the dashboard might have a nice, cute wizard, but you can also do it all from the CLI. And so as far as making sure that we capture the set of users who just say, this is my whole cluster, go deploy the whole thing all at once. I mean, that could be a 30-line bash script that just loops over hosts and disks. There's some work that needs to be done to basically parallelize the work queue in the SSH orchestrator so that you can have a whole bunch of OSDs being created in parallel asynchronously. I think most of the infrastructure to do that is there, and that there is a work queue already. It's just the CLI commands are all kind of blocking, and so they don't feed it more than one item at once. I think that's one of the items we want to sort out.
Yeah. How can we tackle long-running tasks? Because the dashboard, well, it fires off an API call, but it can't just wait for it to return, and because you would run into a timeout. So, basically, integration within the with the progress notifications we have would be nice. We can already visualize all the progresses trapped and captured by the progress module. So that would be one way to integrate that. So basically dashboard probably needs to get a handle of where this job is being tracked and then be able to
query
check the status.
Yeah, I would love to have this married with all the progress stuff. I'm a little bit worried because the progress stuff doesn't necessarily have I guess it does have a unique identifier. I don't know if it has a completion like status, success or failed. We might have to add that. But I think it does also remember completed. That's okay. So if that's the case, then that would be a perfect way to do it, because maybe we could just add like a dash background to like all these imperative commands. So in the CLI, instead of blocking, it'll just fire it off and you can go watch it in the progress stuff. And I think with the drive group, probably one of the next steps is basically, so what I would like to do at a high level is have the equivalent of Rook's use all devices and use all hosts. Not use all hosts because you already have to like add the host explicitly to the cluster, but use all devices, or it'll just hoover up any device that is unused and matches some basic filtering and provision OSD on it automatically. So probably getting something like that to work with one of these drive groups that applies to all devices, and have that trigger like a parallel background OS2 creations would be one of the next steps. Make sure this scales.
So that part is in. We can submit a drive groups back to the orchestrator, and then it runs off and does its thing.
Yeah, I think it's just doing it serially. It's gonna take a really long time. So making that, parallelizing that, because one of where Ansible is really good is if you have 40 nodes with 32 disks per node, it'll just like go to town.
Same with Salt,
Yep.
And that's really one of the concerns that I have. The further we go with this SSH orchestrator thing, the more we will at some point realize that, hey, Ansible or Salt have already done this before. But well.
Yep. Yeah. All right. Yeah, I mean, I think there are sort of two ways to look at that. I've been approaching this from like, how do we make it as easy and painless for the user as possible? And right now, like using Ansible and setting all that stuff is like super painful and tedious. Maybe Salt's better. I think the out is that we could always repackage this later so that under the covers we're using Salt or something like it to do all the remote running later. Like I'm not really opinionated on any of that. As long as the end user experience is simple.
Right.
And right now,
the initial approach about the orchestrator was to have different backends that
exactly.
Load this part to whatever sort of Ansible is used, and we're kind of circling back now. But well, I think the good part about this is that we really try to concentrate what is very Ceph specific business logic, and that only Ceph knows best how to do into the orchestrator now, and then leave the execution to a more slimlined execution using the SSH orchestrator.
Yep. Okay. So what's the next? What else is on the list here? Right. So we talked about labels, parallelizing OC deployments. Sebastian, are you on the call? Yeah. I'm curious. Am I right about what the next steps are for the parallelizing part? Like, can we just take what the drive groups are currently doing, where you submit a complicated drive group and can we make it do it quickly? He's not.
He's there, but he recently left and then rejoined. Maybe he has some more
You might have
audio video
something else.
issues.
Yeah, it's getting late there. Okay. Okay. All right. I want to touch on upgrades really quick. Although this will probably be pretty quick. So there's a pull request open right now that has an upgrade check function. That one's under review and more or less ready to go. There just needs to make its way through the test suite and get a final +1. But basically what it does is it takes the current inventory of all the services that are running, which already gives you what the container ID is, what the container name is, what Ceph version is inside of it, and then compares that to the target version that you specify that you want to run. And then we'll tell you basically which daemons are up to date and which ones need to be updated. And that is friendly in that you can give it like a full container image name, like Ceph/Ceph : a particular tag, and it'll go figure out what should be done. Or you can just give it literally just a version number. You can say 14.2.5, and it will construct the appropriate container image and tag for you, and then do the same thing. So I think that's pretty good. The next step is I have a work in progress that basically implements upgrade start, stop, pause, resume, and status. The start, stop, pause, resume are all pretty simple. They basically just record what the target version is that we want to upgrade to, and that we're in progress. And then pause will just suspend whatever activity is happening. Resume, stop will throw it all away. The last thing that actually has to be implemented is the part that actually does it, where assuming the upgrade is ongoing, then it looks at your service inventory, says are all the monitors upgraded? If not, upgrade the monitors. Are all the managers upgraded? Blah, blah, blah. That just goes through that logic sequence, implementing pretty much what the Rook one is doing. For now, I was just implementing this in the SSH code and not in the generic Orchestrator code, so that we can basically just attach these same commands to Rook as we do to SSH. Later, we can think about whether it makes sense to unify all those into a single implementation that sits above the orchestration API or not. I think it's not completely obvious whether or how that should be done. But one of the main questions that came up, though, is that is just this start, stop, pause, resume thing. I think makes sense from a user perspective. It's what I would want to be able to control if I was doing an upgrade on a big cluster. I don't know that actually works with Rook today, though. Start and stop, or at least start obviously works because it'll just update the CRD to say what the new version is. But I think for pause, resume, and stop, we might want to, those might mean changes to Rook. So,
right, today Rook just starts and goes until it's done.
Yeah.
Retries until it's done.
There's no stopping it. Yeah. So I was thinking for pause and resume, it might make sense to add a property to the cluster CRD that's just like pause equals true, or pause upgrade, or suspend version updates or whatever equals true or something. And basically that'll just make Rook stop updating deployments. Obviously, if a deployment has multiple daemons and it's midway through its thing, then Kubernetes has to finish doing that thing. But Rook at least could pause its work, and so it won't move on to the next OSD or move on from monitors to managers or something like that.
And we might even put something, or not implement it in the CR. It might just be like a config map or some other place the operator can look for this flag. Oh, I'm in the middle of it. Pause it, report it, or whatever.
Okay.
Because updating the CR, just the way it's implemented, it has a hard time seeing those events.
Okay. And I think the same thing with stop. It might be that stop is indistinguishable from pause. It just means that Rook won't update existing deployments, but any new deployment will use the new version that was specified. I don't know exactly, but what the behavior should be there.
Yeah, stop and pause sound the same to me too.
In the SSH case, the difference is just that you can't resume a stop. It forgets what version you were going to upgrade to, but maybe that's a little bit silly. In the Ceph config, there's a container image config option that you can set hierarchically across, globally or per daemon or per daemon type or whatever. And so my plan was basically to make it iterate through the daemons by type and update the container image to be the one that you want. And then once it finishes a whole type, to push it up one level. And so eventually at the end of the day, all the container image config options would get eliminated, and you would eventually replace the global one to be the new version. But at all times, basically, the state of the config map, whatever the mon config, would be the current in progress midpoint upgrade state. Rook does it kind of differently in that you change the CRD to be the end state, and there's no sort of describing what the mid state is.
Right. In our upgrade design doc, we find how that intermediate state could be defined in the CR, but it's not implemented yet.
Okay. It might not be worth it, I guess. But I could imagine that you have a cluster, you start an upgrade, and you're partway through, and you're like, there's something wrong. I got to wait like a week until there's a new update or something like that. And in the meantime, during that week, you might have new OSDs being deployed or something like that, and you want to deploy the old version and not the new version. But maybe we're
right. So
might be getting into the weeds here.
Would help.
Yeah. Okay. Well, in the meantime, just having a pause and resume, I think, is probably good enough. And then we can just wire up the rest. That'll be good. The last thing that was sort of caught my eye was that the API that John originally defined for this a million years ago for upgrade, I think it was John, had a command that would basically list available versions to upgrade from or to. That isn't implemented. I'm not entirely could implement it, but it's a little bit weird because I think we'd have to just go poke at the Docker registry or whatever it is and look at available tags to try to figure out what those versions are. That's a little bit funky, but also I guess this would make sense on the dashboard or something like that. Like you might have a widget that pops up and says upgrade available to whatever version. But I don't know. I'd fine leaving that for future work.
That request has been coming up before. So, yeah.
It has. Okay.
It's on the wish list.
Okay. Yeah, one of the things on my to-do list is to look at, there's some Python module that lets you interact with the Docker registry directly. Right now, in order to, for example, figure out what the current hash is for the latest image that the upgrade uses, it just pulls the image and then inspects it on some random node in the cluster. But it might just be that using the registry API to talk to the registry directly for that would make sense, in which case it would also be easy to do listing tags and versions.
Right, because otherwise, if you have a cluster that has slightly different versions, update available is something that's too vague. You need to be a bit more specific. Which nodes need the updates, things like that.
Yeah.
In a distributed system, there's not just one single version. That's really the thing that we need to solve.
Okay. All right, so all of this, there's one item here on the list that's just it says being more declarative. This discussion keeps coming up in the daily calls. We seem to be inching toward the SSH orchestrator operating in a more declarative fashion. So far, everything we've done is imperative, like you issue a command and it does that. But with drive groups, for instance, or this idea of being able to say, set a flag that says use all devices on all nodes, whatever, pushes more towards a more declarative model where we would store what the description of the state is that we want to be in, and then periodically you could either explicitly go tell it to go do a pass to do an orchestration or whatever, or it could do it automatically periodically. But we do seem to be moving in that direction. particularly with the labels also. Like, for example, if the labels change and daemons were previously deployed based on labels, then at some point probably you want it to like move those daemons around based on the change in the labels, that sort of thing. I think the nice thing is that so far this seems to be sort of a spectrum of how declarative we want to be and how not declarative. So far everything still functions in an imperative way, but we're sort of inching our way more towards the other end of the spectrum. So just something to keep in mind. I don't know if there's any.
I think having both imperative or declarative approaches is a good thing, because some actions like replace this drive,
yeah,
but there's just not a declarative way to do it. So as long as we can support both.
Yeah, I think the declarative behaviors will be built on top of imperative actions. So you'll always have the imperative stuff.
Great.
Yep. Okay, so I guess the last item is the monitoring one, which maybe is a Pandora's box, but there's a thread about this. So monitoring is sort of taken to mean Prometheus, Grafana, as the two main pieces that are necessary to make the dashboard sort of fully functional. There's also something that goes with Grafana that's called Node Alerts, I think, or maybe that, or Alert Manager. Maybe that goes with Prometheus. I forget which.
Prometheus Alert Manager.
Yeah, that one. So I think that would be just deployed along with Prometheus. And then there's also a node exporter, which is the agent, the per node agent that's sending stuff to Prometheus that includes metrics that the dashboard consumes. So I think at a minimum, those are the things that we've identified as things that we want to deploy. The way I've been thinking about this is that we want to have a prescriptive option for people who just want Ceph to come up and have everything work, and that can deploy things in an opinionated way, and probably without much flexibility at all, but just in like some sort of a basic way. And then, of course, there's always going to be the mode where you're a power user, you've already built all this infrastructure yourself, it's already running, or you want to manage it yourself in a different way, in which case, fine, you just set up Prometheus on your own. So using sort of the opinionated out of the box version is thing you may or may not do. And there's like this whole spectrum of, what's that?
Sorry to interrupt, but so is your idea or your expectation to have a kind of the bare minimum to have this working in a proof of concept environment way, or is this something that you expect to be production for people actually deploying real clusters?
I think at a minimum it has to be the bare minimum, but I think that it should be as close to, if not fully, like sufficient for a production system also.
Yep.
But I mean, whether, I don't know if we want to bite off like deploying Prometheus in an HA configuration, like we probably don't want to do that. And what is sufficient for a quote unquote production deployment varies from person to person. Like obviously you're probably going to want some sort of something that's going to make your pager go off. Maybe in some cases that's something that's built on Prometheus. In my experience, it's always been built on something else, but I don't know. I don't know how people are doing these things these days. So I think in my mind, I'm not afraid to make the out of the box turnkey opinionated one like complete and functional. I think that's in the end, that's gonna make for a better experience for users.
There's one thing that is going to be somewhat funny, especially that's the node exporter, which is the service that scrapes your host for performance metrics and everything. We probably need to have one that is running on the actual host in a way to capture this metrics, and then in each of the running containers to get the container specific metrics. So I'm not sure how to realize that. So just another thing that we need to think about.
Why does it need to run inside each container?
Well,
so this is certainly another Pandora's box. You can certainly get away with just having a node exporter per host. It, however, you get more information or better, you get better structured information out of a container host if you actually have the node exporter in the containers too, or often as a sidecar container, though I don't know if that concept actually exists outside of Kubernetes. And the benefit you get from that is that on the host level, you get from the node exporter, you get the CPU stats by mode. So you get, user mode, system mode, IO weight, and such. But you don't actually get insight into a per process level CPU usage, for example. If you put that into the container, you do get, for at least certain modes, the per container CPU usage, which I think is generally something that we would want. Same for obviously RAM and network.
What does Rook do in this case? I mean, Rook doesn't run a node exporter inside every container, does it?
I don't know if Rook does anything there yet. Sorry, go ahead, Neil.
Prometheus is sort of a separate setup process on top of Rook, so I'm not actually sure of the details. I forget.
Oh, and thinking more about this, there's another challenge. Right now, the dashboard uses Grafana dashboards to visualize the performance metrics captured by Prometheus on a per host basis. So we have a list that is called hosts, and that has each host, because we are kind of assuming we are talking to physical hosts here, but all of a sudden we now have a physical host with several containers running on top of them, which are independent entities. I'm just realizing that we need to figure out how to separate that and make sure that make sure that the metrics that we capture are visualized in the right place. Because we at some point then need to have a separation between, well, this is metrics about the physical host, this is the metrics of the individual containers. So yeah, as Jan mentioned, that is really a Pandora's box.
It's a Pandora's box. That only comes up if we're doing the per container metrics,
but
seems a little
really
bit
what the dashboard currently expects.
Yeah, and you could do this with the per host exporter, but then you're kind of in a between a rock and a hard place to correlate which container talks over which virtual interface, for example, to get a network graph in the per OSD dashboard, this kind of stuff.
Yeah.
It's all possible, but it's very cumbersome if you just have one exporter per node.
I guess all of the containers that Ceph daemon is deploying are using host networking, and they all run exactly one process that is the one Ceph daemon. And so I'm wondering if there's actually anything to be learned from individual containers that you don't already know from the host, except, I guess, the memory usage, I guess, inside that container.
Yeah, memory, CPU, and yeah, the network is just easier to extract. And again, I haven't looked if Podman has or what actually goes into a concept of a sidecar container. I think in Kubernetes it's like inside of a pod. I don't know if we could mimic something like that in Podman as well, but that might be a way to go.
Okay.
If it's not too high hanging fruit, it would be definitely nice if we'd actually consider that.
Okay. My guess is that for Octopus, because time is short, I'd be happy just having the host start with, then we can expand from there for the next.
Yeah, that certainly makes sense.
Yeah.
Well, I mean, this is kind of a segue into what the only thing that I would like to make sure in this monitoring discussion I'm not, objecting to the orchestrator deploying any monitoring. What I would just really like to make sure is that it's easy to integrate with external monitoring, and this kind of plays a part here where we really need to have some kind of a primitive or CLI caller, so to get all the exporters that the orchestrator deployed, that we can export that to an external Prometheus, so this external Prometheus can scrape those, and there obviously it's kind of a difference if we deploy one node exporter per node, all these things.
So I think this is the question in my mind of whether, so there's, in one extreme, we're deploying our opinionated, out of the box, pre-configured, all-in-one version of everything, and you don't have to think about it. And the other extreme, you have your own Prometheus set up, and you're installing your own node exporters. You're like running all the stuff, and the orchestrator isn't doing anything. You're just pointing the dashboard at your other Prometheus. It's not clear to me whether we should worry about any of the in-between space, and if we should, how much. So what you just mentioned is sort of an in-between point where Ceph is deploying the node exporters, but it's not managing Prometheus. Like, is that actually a useful thing? Like, is there a situation where you run your own Prometheus, but you don't want to install and run the node exporters?
Yeah, I mean, no, not regarding the node exporters, but we at least have to have a way to expose the manager Prometheus module to an external Prometheus.
Yeah, absolutely, yeah.
And when we do that, we think about, okay, we have a certain requirement of Grafana dashboards that the dashboard expects. That's a JSON blob that wouldn't hurt if we could just go orchestrator, give me the dashboards, and it just spits out a bunch of JSON. Alerts would also be something. Nobody would have to use it, but it would be nice if it just be there.
Yeah. Okay. Yeah, those things all make sense. Like, probably right now for Prometheus, there's a command that you run that tells you what the URL is to scrape. We could add a new command that includes that and any other additional things that could or should be scraped. That would be pretty straightforward. I just don't want to get, I guess I'm less worried about these in-between phases though, because we're always going to support the extreme where you set it all up yourself and you just point the dashboard at your external Prometheus and tell your external Prometheus how to scrape the Ceph manager, and then you're done, and you will, and then everything else is, DIY. But all these sort of hybrid scenarios are like, it's going to, if it starts to get complicated, then like I'm happy to walk away from it.
Sure. Though I think it won't be all that complicated because it's really just exposing, some structured information one way or the other. Like nothing that's complicated to come by.
That sounds good. Yep. Okay. Jason had an interesting question in chat. He said, will we configure Prometheus to store its data on RBD? Which is something I hadn't considered at all, actually, but I wonder if it's something that we should consider.
I'm wondering if, yes, we could certainly do that, but CephFS might actually be the better option. Yeah, mostly because of the elastic growth, right? If you decide, 10 days of history isn't enough, I want a year, then that wouldn't involve, putting in a new RBD image.
Yeah, it does. So, I was assuming that we would just plop Prometheus on one node and it would be a single point of failure. And if it died and you had to redeploy to Prometheus, then you would just lose your metrics and you would reset. You'd start over again. It'd be fine.
Yeah, I've actually thinking about this for a second. It's probably not a good idea to have that in Ceph because we do want to use that for, observing Ceph and alerting on Ceph. And if Ceph goes down, all our monitoring and alerting is broken. That's kind of against the point.
Yeah, especially if we're doing alerting. Yeah. It also adds all this complexity where that means that we would be like mounting a file system. We have to start worrying about kernel versions and client side. Whereas so far, everything the orchestrator has done is just deploying containers that run daemons and nothing else. So it makes our lives a little bit easier.
Yeah, I think, and that fits the approach of, you have a turnkey solution, or if you want more control over things, you just roll your own.
Yeah. Okay. Okay. I think there's one more implementation question I had around the monitoring. There's Prometheus and Alert Manager, and Grafana. But those, Paul had started to write a script that is separate from Ceph daemon that deploys all those things, but he did it in a different way than Ceph daemon did. So it excuse me. The main thing is that it put everything in Etsy, and then when it runs the container, it would bind the things in your host Etsy into the containers Etsy. The way I made all of the Ceph stuff work is that everything for everything basically is in varlib Ceph FSID and then the container name. So the monitors, each daemon's config file and keyring is in its data directory, just so it's like neatly compartmentalized in one place, and the host configuration isn't polluted by things that are sort of particular to the cluster. The exception to that, of course, is there's a systemd unit that starts the container, and that lands on the host in Etsy systemd. Should we follow the same pattern for the monitoring, so that it would be varlib Ceph FSID Prometheus with all of its configurations and data all on that one directory, and have it running in a container so it only doesn't pollute the host?
Probably makes sense, even though we need to be aware that that var directory is then going to fill up quickly because Prometheus eats disk space for breakfast.
Yeah, it's the same thing for the monitors, although they're probably not quite as hungry. But yeah.
But Prometheus already is putting their data, so mostly the metrics, into varlib, and it expects, default for config is Etsy, but I think that can be changed. So yeah, I think having a tidy approach that mimics what Ceph daemon does makes sense.
Okay. And so then the second part is, should we just put this all in Ceph daemon? So that, right? I mean, this is by what I was originally assuming we would do, where you would do, instead of doing Ceph daemon deploy, manager.x or whatever it is, it would be Ceph daemon deploy Prometheus, and then there'd be an argument that passes a JSON config or something like that.
For reference, we do have a Docker-based development environment that we use for most of our dashboard development work, and we basically spawn a different Docker container for both Prometheus, Alert Manager, and Grafana, and then have some scripting around it to connect it. So if you want to take a look at how that's done over there, I pasted the link in the chat here. Dev Docker is the name of that. We do have a what's it called? Give me a second. Docker Compose YAML file that sets up this environment. And the README tells you how to connect them with each other. Just for some.
Yeah, I'll pass it on to Paul. Yeah, I think what we have, if I have a similar question to answer of how if we want to have a container for Prometheus, a container for Grafana, and a container for the Alert Manager, or we just want to like bundle them all to one container.
I would advise against that. I mean, that Ceph container image is already quite big, and
well, it wouldn't be the Ceph.
We can simply.
Yeah, I'm assuming it wouldn't be the Ceph image. It would be a new image. Yeah.
Oh, upstream Prometheus and Grafana do have Docker images already, and that's the ones that we actually use in
Perfect. Okay.
That makes it pretty
Yeah.
straightforward.
And that
That's what we want.
that
Okay.
also makes sense because Prometheus has had updates in the past that break the metric store, like break the format and stuff like that. You don't want to run into something like that just because you want to upgrade Grafana or something like that.
Yeah.
And they're also meant to be that way. I mean, Prometheus has its roots in Kubernetes, right? So
Yeah. Okay.
and yeah, as for your question, I think it makes sense to just throw it into Ceph Daemon as well, though that particular bike shed might need repainting, but if it's it's meant to be opinionated, so why not have an opinion on it?
Okay. Okay. I guess on that topic, one of my last questions is whether we should rename Ceph Daemon something else that's a bit more suggestive of what it is. One idea was calling it Ceph Bootstrap, or Ceph Boot or something. I think
Guess you
actually
don't want to call it Ceph Deploy, right?
Ceph Deploy is the most appropriate name, but unfortunately that name is taken.
Ceph Deploy 2.
Or just Ceph Container, but that might be confusing.
That's also confusing. Yeah. It's a little bit weird because it has part of it does all of this stuff behind the scenes that's plumbing for the SSH orchestrator. But then there's also a handful of user-facing commands, like the shell command and the bootstrap command and the logs command. So having a tool that sort of captures both of them is a little bit tricky. But Ceph Daemon I find confusing. Forgetting exactly why it was. But
is a little long, maybe. That orchestrator. Orchestrator is kind of an overloaded term too. Maybe not.
Yeah.
Oh, then it sounds like orchestrator modules in there. So yeah, I don't know.
Yeah.
I do kind of agree that just in conversation, when I hear Ceph Daemon, like when I don't see it written out, I feel like it's a little confusing. I don't know if I feel like Ceph Bootstrap is a better name, but it may be a better name in that it would be less confusing in a conversation.
Or Ceph Boot.
Yeah. So one could argue it does a little more than just bootstrapping Ceph.
Yeah. Well, it bootstraps Ceph clusters. It also bootstraps daemons, I guess. Kicks them out of
the Ceph boot. Manager is already taken.
Yeah. Ceph daemon tool.
Ceph.
What the original thinking was.
Manage.
Ceph tool. Just call it Ceph tool. Oh, because I know why. Because there was
the same thing.
There's one other thing that I really want to exist somewhere, and probably in the same tool. The one thing that Ceph deploy does today still that nothing else does is it knows how to configure repositories for packages. So when it comes time to install all your client packages, or if you want to install packages on a bare metal host, I still use Ceph deploy. There's nothing else to do it. It would be nice if that were built into this tool, so it could just modify your local repositories. It understood APT and DNF and RPM and Yum and Zipper and all that stuff, and it knew where to get development packages and it knew where to get release packages and so on. And one of the things that I would like the Bootstrap to be able to do, Ceph Daemon, whatever the script ends up being called, is to have just a prepare command that will just install the minimum requirements for the host in order to be managed, which would be podman and Docker and LVM, I guess. And maybe Crony, or I don't know, whatever it is. And installing packages means that it also probably should be smart about understanding what distro it is, and therefore this is the command I should run to install a package correctly. So I could imagine making a standalone tool that just does repositories, but you would end up replicating a bunch of that logic here for the prepare phase. which I guess is a roundabout way of saying that a generic name like Ceph tool or Ceph boot or something might be good.
Thing is, that initial preparation phase is very distro specific.
Yeah.
And
yeah.
It may also depend on what tools are or deployment tools are being used at the user's data center already to get this out and running. They may have their pre-configured Pixie boot servers to get bare OS images deployed somewhere. So, I mean, that's a small piece of the puzzle. I'm not sure if we should really get down to that level.
Well, we have a check command right now that just checks to see if the commands are there. Is there a podman or a Docker, and LVM commands, are they present? And that's I think the bare minimum. But what I'm thinking is like this get started, these are the 10 steps to follow to install the cluster. Right now it's like, by the way, you need to have podman and Docker installed. And I don't want to have a big thing like, if you're on Debian, run this. If you're on OpenSUSE, run Zypper, blah, blah, blah. It'd be nice to just say, this should do it. Run ceph-daemon prepare. And it will just, kind of like our install deps script in the source repository, does its best.
Yeah.
And or nothing if everything's already present, I guess. So that was sort of my aim. I imagine that for most downstream products, usually there's some infrastructure that's being used to deploy your software, and so all the stuff is already taken care of, and this doesn't actually matter. It's mostly for upstream users.
Exactly. I was just about to say this probably depends which hat you're currently wearing. From an upstream perspective, having a script similar to install deps probably makes sense. It may be a small shell script on steroids does the job here.
Yeah. Okay. Anybody, can I bother everyone to just like throw out ideas and vote on a new name, or not at all? Or I'll put a pad up here. People can just put like a hash mark or something. Boot.
And for what it's worth, while we're talking about deployment tools, since we do have that downstream requirement for our next product, we are planning on having a small salt-based tool that does what you were just talking about, creating SSH keys, setting up NTP, and making sure that Podman is installed. So this very basic step that you need before ceph-daemon can take over is currently done by a collection of salt formulas in our case. That's
I think
the tool of the trade that we are using for downstream. And if you are curious on how that's done, I can share the link to that as well.
Okay.
Why not just call it ceph-d or, everything else, kind of nice short.
Yeah. Cool. Yeah, I kind of like that actually.
Or even cephctl to stay with Linux kind of things.
Not quite a CTL, like the Ceph CLI is like the Ceph CTL usually. Ceph install. Yeah. All right. Well, everybody, please weigh in, because I can't decide what to do. But I'm pretty sure ceph-daemon isn't quite right.
Yeah, I'm sure you get lots of input. I mean, who doesn't love bike shedding, right?
Yeah, exactly. Yeah.
Shame that Ceph bike shed is so long.
Ceph bike shed. Yeah. You call it like tentacle or something. Anyway, okay. I think that's everything I had on my list. Other questions, comments, topics, thoughts?
Just Sage, for your reference, I pointed this to our Docker-based environment and to that bootstrapping tool that we have to the wiki page for the CDN. Doesn't get lost.
And this cessboot, is this a new one or based on the new stuff?
Correct. That's
Yeah, okay.
our intended plan for SES7, which is our Octopus-based downstream product. Since we don't need deep C anymore, we basically had to figure out something else.
Yeah, okay. And this is going to be...
As I said, it really just does the minimum use SUSE Enterprise Linux, SUSE Linux Enterprise Server as the base OS, and then just install the required packages, configure NTP, some firewall stuff, just the basic OS preparation, making sure the services are running, and then you hand it over to SSH Orchestrator.
And it's a salt, right? This does.
It's salt formula, so it's a different implementation compared to DeepC. Much trimmed down because simply all the Ceph-specific logic that DeepC used to have is now in SSH Orchestrator, or it's going to be there pretty soon. So this is offloading us from quite a ton of stuff. But we still need to have something that integrates with our deployment tools that we have as other products, but also something that works as a standalone solution in case customers just want to buy the Ceph-based downstream product and nothing else.
Okay. Cool.
Oh boy, too many names to choose from.
I know, yeah. Got lots of 0 and 1 vote. Cool. Okay. Anything else? All right. Thanks, everyone. Have a good Wednesday.
All right, see ya.
Thanks, guys.
Thanks.
Bye-bye.
Bye.
See you guys. Thanks.
Thanks, bye.